Namaskar, myself Subodh Kumar Singh, and today I am going to discuss a chapter System of Particle and Rotational Motion of class 11 Physics. In this video, I will discuss mainly three terms, and these terms are: first, what we mean by rigid body; the second term I will discuss translation motion, mainly focus on the concept of translation motion and its types. There are two types of translation motion, rectilinear and curvilinear, that I will discuss further. And third one, rotational motion. There is no basically the types of rotational motion. I will just discuss the concept of rotational motion. Let's discuss the first term, rigid body. Now, what is the meaning of rigid body according to physics? In physics, a body is said to be rigid body. I will write the definition in very short word. The rigid body, a body is said to be rigid body, is said to be rigid body if its internal particles, what? Internal particles. Here we are talking about the internal particles. Internal particle doesn't change its position, under the influence of force. Let me clear by the help of diagram. Let's suppose I have taken a body. Let that body be X. I know there are lots of particles present in this body. Infinite number of particles are present in this body. But in order to explain in a simple way what I mean by rigid body, I will take only two particles. Let the two particles be A and B. Okay. Now, when I apply a force F on this body, and the position of this particle A and particle B does not changes. When I apply a force on body X and the position of particle A and particle B does not change, then we will simply call it as rigid body. Okay. When its position get changes, let's suppose that after applying a force F on the body X, the position of A get changes to here. Now the particle A comes here and the particle B comes here, then it is not a rigid body. Okay. The second term is translation motion. Translation motion. Before writing the definition of translation motion, I want to clear the concept of translation motion with the help of diagram. Okay. Then I will first of all draw the diagram, clear the concept of translation motion. Then I will write down the definition of translation motion. So, first of all, I have taken the two body X and body Y. Okay. These both the bodies is at their initial position. These both the bodies is at their initial position. And when I apply the force on body X, let it be F. When I apply the force on body X, then this body moves in a straight line. Okay. And after covering its motion, it's come to its final position. This one is the final position of body X. Okay. Again, I applied the force on body Y, but this time the body Y moves along zigzag path. Okay, moves along zigzag path and after completing its motion come to its final position. Here it is the final position of body Y. As usual, I know there is infinite number of particles present in a body, but instead of this I will take two particles in body X. Let it be particle A and particle B, and let the particles of body Y be C and D. And this time I will not just take the two particles, but I also draw a line segment. This line segment is AB. Sorry, it is not straight. This line segment AB, and I will draw also here also line segment CD. Now, when after completing its motion, obviously the particle's position will not change. Why? Because it is a rigid body, and we have already studied that in rigid body the position of particles doesn't changes even when the force is applied on a body. That simply means that the position of particles is same as it is in initial position. That is the position of particles. Particle A is here, and the position of particle B is also at the same place, that is B here. Okay, I will draw a line segment here also. In the same thing I will repeat here also. I will draw particle C here and the particle D here. Okay, and draw the line segment. Now start observing both the line segment drawn at the initial and the final position. Start observing. I observed that the line segment drawn at initial position, that this line segment AB drawn at initial position, is parallel with the line segment AB drawn at final position. In this case also, it doesn't matter the body is moving, doesn't moves in a straight path, it is moving in a zigzag manner, it doesn't matter. But when I observe, I observe that the line segment CD, which is drawn at initial position, is parallel with the line segment CD drawn at the final position. Means what? Actually, students, the translation motion definition or the concept of translation motion doesn't depends on the path followed by the body. Then what thing it depends? It basically depends the line segment drawn between any two particles of that body. Okay, I have drawn a line segment AB between any two particles. You can take any two particles. I have taken the two particles A and B for the X, and for the Y I have taken the two particles C and D. Okay, and after that observe that the line segment which you have taken must be parallel with the line segment when the body is at its final position. If it's so, then say that the body is in translation motion. Okay, it doesn't matter, I repeat once again, it doesn't matter which type of path the body is following. On which thing the translation motion depends? It depends on that line segment which you have drawn between any two particles of the body. If that line segment is parallel with the line segment parallel with the line segment where the body is at final position, then you can say that it is a translation motion. Okay, are you getting the concept of translation motion? Now let's talk about the types of translation motion. There are two types of translation motion. One is curvilinear translation motion and another one is rectilinear translation motion. Then how will you define the rectilinear translation motion and curvilinear translation motion? Now it's the time of the path followed by the body. If the path followed by the body is a straight line, if the path followed by a body which is in a translation motion is a straight line, then it is called rectilinear. Okay, if the path followed by a body which is in a translation motion is on a straight line, then it is called rectilinear. And if the path followed by a body is curve or zigzag path, which is already in a translation motion, then it is called curvilinear translation motion. So I hope so you get the point. What do you mean by the translation motion and the types of translation motion? Okay. Now I will write the definition of translation motion. Okay. Definition of translation motion, and I hope so the concept of translation motion you get clear. Now the definition of translation motion: if a line drawn between any two particles of rigid body. Okay, always in this chapter we will talk about rigid body only. Okay, if a line drawn between any two particles of a rigid body remains parallel. What? Remains parallel. I have already said remains parallel after the body completed its motion. Then the body is said to be in translation motion. Okay, I once again repeat that the translation motion doesn't depends on the path followed by the body. It just depends on the line segment drawn. Okay. The types of translation motion depends on the path followed by the body. If the path followed by a body is a straight line, then it is called rectilinear translation motion. And if the path followed by the body is curved line, then it is called curvilinear translation motion. Now let's move towards rotational motion. Rotational motion. First of all, I will write rotational motion. First of all, I will write the definition of rotational motion, then I will discuss with the help of diagram. Okay. What do you mean by rotational motion? What do you mean by rotational motion? A body is said to be in rotational motion if each and every particles of that rigid body, except what? Rigid body पहले definition को complete कर लो. If each and every particles of that rigid body is in circular path except a single particle. That particle is except a particle which is situated at axis of rotation or CM. That is not chief minister, it is the center of mass of the body. Okay. So first of all, I will discuss the rotational motion when there is actually the axis of rotation is present. Okay. After that, we will discuss when there is not actually the axis of rotation present. Okay. So first of all, take a body. This one is a body, and I pivot this body at the particle A. Pivot means, which you know na, I have just that simply means that this is my axis of rotation, and when I apply the force, see carefully, let's suppose this one is axis of rotation, or here I pivot this body, and when I apply the force, what happened? See carefully what happened. This body moves like this, comes here, then again comes here, then again comes here, Okay, and then again comes to its initial position. Okay, let's suppose I have taken two another particle which is not present listen to me carefully. The particle A basically present at axis of rotation. This one is axis of rotation. Okay, now I have taken two particles B, this blue one, B, and C, which is not present at axis of rotation. These are another particles which are present in a body but doesn't present at the axis of rotation. Okay. Now when I apply the force, the body start rotating like this and it moves like this, and again moves and then again comes in its initial position and it moves in a rotational motion or in a circular motion until I have applied the force. Okay. Now start that simply means ki this particle B moves here and the particle C will be here if the body is at this position. Now the particle B will be here and the particle C will be here when the body is at this position. Again the particle B will be here and particle C will be here when the body is at this position. Now start joining the path followed by the particle B. When I join the path followed by the particle B, I come to observe that this is circular path. Okay, let me use one more color. When I join the path followed by C, then I again comes to observe that this path is actually the circular path. And this is what we call as rotational motion. What is rotational motion? A rotational motion is a motion in which each and every particle of that body is in circular path, as you have seen in B and C. Except which particle? Except that particle which is present at axis of rotation. Suppose that I have pivoted this body at this one, then this one is axis of rotation. Okay. So accept the particle which is at axis of rotation or at CM. That will I will discuss later. Okay. Now let's discuss the rotational motion when there is no axis of rotation exist actually. Okay. I have taken a rod and when I apply a impulse at this corner, what I have said? I had applied an impulse. What is impulse? Impulse is basically a force which is having large amount and applied for a very short period of time. For example means when I apply a force by a hammer on a nail, then that force can be called as impulse. Okay. So here I have applied an impulse at the corner of this rod. Then what happened? This rod start rotating like this. This rod start rotating like this. Okay, this rod start rotating like this. What you have observed? You will observe that there is no any axis of rotation, isn't it? There is no any axis of rotation, but instead of this, the body is moving while moving in a rotatory in a circular path. While rotating along a circular path, it is rotating along a fixed point or an imaginary axis of rotation. Along a imaginary axis of rotation, this body is moving along an imaginary axis of rotation which passes through a point, and this point is called CM of this body, that is center of mass of this body. What happened when there is no any axis of rotation, and at that time when you are applying a impulse or a force at the corner of the body, then that body start rotating. At that time when it is start rotating, it is rotating along an imaginary axis, and that imaginary axis passes through a single point, and that single point is called CM of that body. So let this let the particle which is lying at this CM be A. Okay. Now let me use some more colors. I have taken just like the previous figure, I have taken the two more particles which is not lying at the CM but lying another place. Let it be B and C. Same thing I will do. Now after rotate, when the body comes at this position, obviously the position of B and C changes. Again the position of B and C is like this, and again the B and C is here. Now just like a previous one, when I join the path followed by the B, then I observe that this is a circular path. Sorry, it is B here. And again when I join the path followed by C, again it is a circular path. Now what is rotational motion? A rotational motion is such motion in which each and every particles of the body, as you have seen in this figure, moves in a circular path, except which particle? Except the particle which is lying at the CM of the body or at axis of rotation. Now in this video it is enough. I will discuss more terms in my next video. Thank you.